Yeah, I thought I'd show you real quick how I use my fan card to talk about Newton's third law, and then also to give them a little preview of some things we'll get to later in momentum. This is an old sort of home-built fan cart, kind of dangerous. Hopefully you have one with a cage over it. That should work for this demo as well. And so when I turn it on, it moves. And so as far as Newton's third law goes, the propeller pushes on the air, and the air pushes back on the propeller. When we talk about how cars accelerates, we bring up the fact that it's the road that pushes the car. The car has a powered drivetrain and spins the wheels, that pushes backwards, and then the road pushes forward. So you can ask the students, in this case, is it the road that's pushing the car forward? And it's not. There's essentially no friction acting on the wheels. It's the air pushing the propeller. So now I introduce the idea of a sail. I want my car to go even faster, so I'm going to put a sail on it. So how is that going to affect the motion? And so you could have students write down what they think. A good technique is you put a list on the board and you just ask them to offer what are all the possible things that can happen. So you don't have them stick their neck out and make a prediction. You just say, hey, what could happen? It could go forward, it could go backward, it could stay at rest, it could go faster forward, faster backward, and you get a whole list up here. Then you ask them to pick from the list what they think is going to happen. That's a little less intimidating than what is going to happen. So I have them answer. Most of my students think it's going to go slower because we saw this in a Roadrunner cartoon on the first day of school. And so I turn it on, and I tell them, well, I guess if you said slower, you're right, but it's actually not moving at all. So now let's see what's going on. So we still have the propeller pushing on the air pushing on the propeller. That is a Newton's third law pair. And the air moves as well, and now it's moving and hitting the sail. So a separate pair is the air pushing on the sail and the sail pushing on the air. The air kind of squeezes out the sides there. It's kind of hard to imagine it. But the key thing is the push by the air on the sail is not a Newton's third law pair with the push from the air on the propeller. And they could be different sizes. So I've carefully chose a sail that would make it so they're about the same size. A note to you physics teachers, if your cart is very easy to roll, it's very hard to adjust the sail so that it would do this. If you want to cheat a little bit, I wasn't cheating here, but my cart has significant friction, at least more than some newer carts. I could move the sail so it's rubbing against the wheel. Now, is that okay to trick your students like that? I think it is if you know that ideally you could get it to not move. So I'm lucky I'm able to get mine to not move. You could put yours on maybe a cloth or something, or try something if doing that is against your ethics. And so the cart didn't move because those forces were the same, but what if I use a sail like this? So now what's going to happen? I still have the air pushing on the propeller pushing on the air. I have the air pushing on the sail, and the sail pushing back on the air. But with this hole, how are these forces going to compare? And most of them see that now the force backward of the air on the cart is not the same as the force forward. The force forward's probably bigger, and so it's going to go. And again, you have this list of possibilities on the board they can pick from, and going forward to their right, but slower is how it works. And then lastly, I just introduce them to this idea. Now I have a large sail that you think might work like this one, that we get equal forward force from the air and a backwards force, so it wouldn't go. But because it's curved, some of them can see, hey, the air is going to hit now, and it's going to, some of it come back. And so what is going to happen now? And so again, you have a list of possibilities, and you turn it on, and it does go the other direction. You could call it backward, And so this is what the coyote was using in the Roadrunner cartoon, and we were saying, hey, that wouldn't work well, and we can see it doesn't work well, but it sort of can work if you shape the sail, and this gets into momentum. Now the air is hitting the sail and bouncing back. And so a bounce imparts a larger change in momentum, a larger force to the sail than what it does to the propeller, and so you actually get the pushing of the air on the sail this way is more than the pushing of the air on the propeller back this way. There's probably some other things going on, but that's my major point that I'll make later. I didn't tell them what was going on because we'll get to this later, and so I'm sort of sowing seeds of further investigations. So if you have a fan cart, there's a lot of great things you can do with them, but this is more of a demonstration. And if you have one like this, don't let the kids use it.